Hey guys, today we are going to talk about the unit circle a little bit more, and we're going to talk about reference angle. So first of all, you need to know that the unit circle is frequently used to map 35-degree angles, 45-degree angles, and 60-degree angles, and their multiples. And it's also used to look at the 0 or 360 degree, the 90 degree, the 180 degree, and the 270 degree. And this unit circle is probably a little bit difficult to see, but you can see that you have the 30, 45, and 60. And then here's your 90. And then you're going to add 30, 45, and 60 to those. So you'll get 120, 135, 150. And there's your 180. And we're going to do 30, 45, and 60 again. So 180 plus 30 is 210, 225, 240. And then there's your 270. And then we're going to add again 30, 45, and 60. And we're going to get 300, 315, 330. And then finally we're back around to 360. And then we also have those in radians. So pi over 6, pi over 4, and pi over 3 are your basic angles that you're talking about. And then pi over 2 is the quadrantal angles. So we still continue to add pi over 6, pi over 4, and pi over 3 to get those three angles. And then pi over 2 plus pi over 2 is just pi. Then we're going to add pi over 6, pi over 4, pi over 3. There's another pi over 2, pi over 6, pi over 4, pi over 3, and then another pi over 2. So we're just basically using the same set of angles all the way around the unit circle. And when you look at their coordinates, you can see that the numbers basically stay the same. We just change the signs. So we're going to start by reviewing a little bit to find the value of each trigonometric function. Remember, on the unit circle or on the coordinate plane, when you draw an angle to a certain place, okay, the coordinates for this point are going to be its cosine and then its sine. So the x-coordinate is the same as the cosine, and the y-coordinate is the same as the sine. To find the tangent, we're going to take the sine divided by the cosine. Okay, so I'll show you how that works in just a second. So if I look at sine of 135, I know my 135 angle is past 90, so it's in this quadrant here. And if I look it up on the unit circle, the coordinates are negative square root of 2 over 2, and then square root of 2 over 2, which makes sense, right? I have to go negative in the x direction and then positive in the y direction. And I keep drawing these as arrows, and I really should draw them as points. So I went negative square root of 2 over 2 to get to this side, and then I went positive square root of 2 over 2 to get up. The sine is the same as the y coordinate, so my sine is just the square root of 2 over 2, and you don't need to change it for anything. The tangent of 270 comes straight down, so its coordinates, I go over 0 and up -1. And so tangent is the sine over the cosine, right? Because it's the y over x. And so I'm going to do -1 over 0, which when you try to put that in your calculator, you're going to get undefined. The cosine of -150. Now remember, for the negative angles, you're going backwards. You're going down instead. So -150 is here. The coordinates are going to be negative square root of 3 over 2, -1/2. And the cosine is the same as the x-coordinate. So my cosine is going to be negative square root of 3 over 2. We do the exact same thing with the radians. The cosine of square root of, or 3 pi over 4, so 3 pi over 4 is going to be in that second quadrant, so it's going to be up here. So the coordinates for that are negative square root of 2 over 2, comma, square root of 2 over 2. So the cosine is going to be the negative square root of 2 over 2. And then tangent of 2 pi over 3, so 2 pi over 3 is in this quadrant up here. And the points are going to be negative 1/2, and then square root of 3 over 2. And so to find the tangent, I put the y coordinate over the x. So that's going to give me square root of 3, or we'll say sine over cosine. So square root of 3 over 2 divided by negative 1/2, which is just going to give me negative square root of 3. So tangent of 5 pi over 4, 5 pi over 4 is in this area down here. So its coordinates are negative square root of 2 over 2, negative square root of 2 over 2. So remember, it's sine over cosine, or y over x. So that's going to say negative square root of 2 over 2 divided by negative square root of 2 over 2. And that is going to give me a positive 1. So the reference angle is the distance or the angle between the angle I'm talking about, whatever it is, and the x-axis. So whatever this angle is, or if I'm down here, whatever this angle is, or if I'm up here, whatever this angle is, or if we're down here, whatever this angle is. So it's always between the angle I'm given and either the 180 or the 360. Okay, so you'll see we're going to do the same thing for all these over and over again. I'm going to figure out where's my angle. So 150 is in this coordinate or quadrant. And if 150 here and 180 is here, I just need to find the distance between the two. So I just take the bigger one minus the smaller one and subtract, and I get 30 degrees. For 315, it's down here. So there's 315. Here's 360, and I need to know that distance. So we're going to subtract 360 minus 315, and we're going to get 45 degrees. Now here we have negative 240. So negative 240, remember we're going around the opposite direction. So 240 is going to go past 180, so it's going to be up in this quadrant. So if I do 240 and then 180, I still subtract the bigger one from the smaller one. So 240 minus 180, because I just need to know this distance. So the sign is always going to be positive. So I'm going to get 60 degrees for that. Now 5 pi over 3, first you have to find 5 pi over 3, and you can use your unit circle to do that. 5 pi over 3 is down here. And here's 2 pi. So we're just going to do 2 pi minus 5 pi over 3. And you'll just put that in your calculator. That is going to give you pi over 3. All right, so this angle here is pi over 3. 7 pi over 6 is going to be here. So I'm going to do 7 pi over 6, and then pi is on this side. So since 7 pi over 6 is bigger than 1, or then bigger than pi, I'm going to subtract that way, and I'm just going to get pi over 6. And then finally we have negative 5 pi over 4, and remember that's going this way again, and it's going to end up in this quadrant up here. So 5 pi over 4, and here's pi. So 5 pi over 4 is bigger, so we're going to start with that one. Minus pi, and we're going to get pi over 4. Okay? So this is just basically review. but I'm going to go through these with you guys to make sure, because a lot of these are very similar to what you're going to see again. So sine of 120. So sine of 120 is here. The coordinates are, let's see, 1/2, negative 1/2, square root of 3 over 2. Ooh, you can barely read that. But the sine is the y coordinate, remember, so square root of 3 over 2 is your answer. The tangent of 11 pi over 6, 11 pi over 6 is going to be here, and its coordinates are square root of 3 over 2, negative 1/2, because you go to the positive direction and negative direction. And here's your special right triangle, by the way. But to find the tangent, I'm going to do negative 1/2, because remember it's sine over cosine. Negative 1/2 over square root of 3 over 2. And when I put that in my calculator and let my calculator do my work for me, it's going to tell me it's negative square root of 3 over 3. And we can get in the algebra later if you'd like to. All right, on the unit circle, the order paired for an angle is below. Determine the measure in degrees. So what I look at first is that my x-coordinate is positive and my y-coordinate is negative. So if I go positive and then down, this is where I'm going to be in this quadrant. And the coordinates are square root of 2 over 2, negative square root of 2 over 2. The question is, determine the measure in degrees of the reference angle. So we're going to do what we did before. So I need to know what that is, and this is 315 degrees. And remember, this is 360, so I'm just going to do 360 minus 315. And you may be to the point now where you start recognizing these coordinates. When they're the same like this, they're multiples of 45. So you might just be able to look at that and know off the top of your head. All right, this ordered pair is negative and negative, so we're going to be down here. And negative 1/2 negative square root of 3 over 2 is going to give us a 240 degree angle. And here's our 180, so we're just going to do 240 minus 180, and that is going to be 60 degrees. All right, so then we have, on the unit circle, determine the radian measure located at square root of 3 over 2, comma, 1/2. So that's going to be up in this quadrant somewhere. And so we're just going to look on our unit circle, and we're going to find out that that is pi over 6. Here we're going to do negative 1/2. So we're going to go negative and then positive. So we're going to be up in this quadrant. And when we look up these coordinates, we're going to see that we are at 2 pi over 3. All right, determine the value of cosine of t. So we don't know what this angle is, but we know this coordinate set. So we know that the cosine is the x coordinate. So that just leaves us with square root of 3 over 2. A unit circle has a central angle of theta. In the figure, x equals 1/2. So if x equals 1/2, that means that x has to be positive. So we're going to the right. Determine the distance in units along the unit circle from the point 1, 0. So this is really wordy for no particular reason. To the point x1, y1. So if we know that the x coordinate is 1/2, that means that the y coordinate has to be square root of 3 over 2. And in this question, we don't know if we're going up or down, but it honestly doesn't matter because this coordinate is 1/2 negative square root of 3 over 2. And what we're supposed to find is the distance along the circle. So, you know, if we have our circle here, the distance, it doesn't matter if we use this point or this point, it's going to be the same. So, we need to find this distance here, which remember is the same as the radian measurement. So, if the radians are pi over 3, we can either write pi over 3 or we can convert that to 3.14 over 3, which is 1.05. So you can write either one, and you need to be able to recognize that those are the same. So this is the same as this. We just substitute 3.14 into our calculators. An angle measures 3 pi over 2 radians. Approximately how many radian units along the arc does that represent? Well, 3.12 or 3 pi over 2 is the same. We can convert that to 3 times 3.14 over 2, and we would get 4.7. So we can either write it as 4.7 or 3.12. And finally, we are looking at Mrs. Willett was finding the exact tangent of 315 degrees. Her work is below. State the mistake and work the problem correctly. So we're looking at her ordered pair at 315, but remember that 315 is down here. So that means I should have a positive x value, but a negative y value. So right away, we can say that her mistake was that the coordinates should be square root of 2 over 2, negative square root of 2 over 2. So that is where her mistake is. And so if she does sine over cosine, what she should have is negative square root of 2 over 2 divided by positive square root of 2 over 2. So her tangent should be negative 1. Let me rewrite that. So that's what she should have gotten. Okay, I think that's everything. If you have any questions, just let me know.